Thanks again for taking time for being here today, and welcome to today's episode of examining recent Microsoft, Zoom, and Google outages. In today's episode, we will review the IT challenges which our users, IT operations team, network teams face in the work from anywhere world, and give you an overview of the Zscaler Digital Experience monitoring solution, and then look at some of the recent outages through the lens of Zscaler Digital Experience Monitoring, followed by a quick live demo. So, in the end of this session, we will leave you with a solid foundational understanding of how Zscaler Digital Experience enables you to proactively monitor issues while when they impact your users and get to the root cause of issues quickly. I'm Vikash Srivastava. I'm your host today, and I have spent more than a decade working in the networking, security, and the application visibility domains. And I'm here with my colleague Rohit, who will be helping with the session today as well. So, outages are unfortunate and it happens to everyone. So this by no means is putting blame on one provider versus other, but it's basically like everyone at one point of time gets impacted by an outage. But the real important part is how do you quickly identify these outages and understand where the actual issue lies, right? Many times without the right tools, IT teams assume that the problem is on our side. The user starts complaining, we see a blip on the network, application isn't accessible. IT teams get on and start troubleshooting where the problem lies. But what happens a lot of times is that a lot of precious time is wasted, and uh, the employee the support team's time and employee productivity is impacted in this whole process. Now, let's take a look at the simple example here. So, when an end user experiences an issue, it can show up in different ways, right? Sometimes it appears as a slow device, sometimes it appears as the application is not accessible, right? So, in this case, we have a user complaining about not being able to connect to the application Zoom, not able to log in into one of his or her meetings. Now, the end user goes and complain, like opens the service desk ticket, and basically service desk, the level 1 or level 2 service desk starts with their standard run book of looking at what's your IP address, is everything fine on the device, what's the network look like, is the application. So they start checking all of these things one by one, and we know that this process isn't always quick. It takes a lot of time. So the troubleshooting process, the whole cycle is extended now, and it creates a poor user experience. So what could be happening when a user reports a problem is that the problem could be into one of the many different segments, right? It could be the application itself, it could be the user's device, it could be your local network, or it could be the ISP, or it could be the upstream provider's local network. How do you know, right? Now, all of these all of a problem in one of these segments can portray in one or different ways. Right now, the example where we're talking about the user created this ticket, there isn't enough data to quickly get to the root cause of what could be causing this problem. Now, what's missing is the context sharing between all of these different pillars. So that being said, let's do a quick poll, right? What are your challenges with existing monitoring solutions? So you can put your answers in the chat panel here. Again, what are your challenges with existing monitoring solutions, right? The first one is too many dashboards, right? To different tools. So too many dashboards for correlating, issues increases troubleshooting times. The second one is no insights into the user's home Wi-Fi or their local ISP. So if the user is opening a case from their home, we don't have visibility into what their home Wi-Fi looks like or their local ISP. And the last one here is too many escalations for basic networking and security issues. So I'll give you a couple of seconds to go put your answers in the chat window and we can move on. All right, thank you. So, most of our customers have a network and security architecture which has evolved over time, right? Their networks have expanded and grown, in a way like try to make sure that their employees are secure when they're working from home, their experiences are good, and deploying firewalls on VPNs to enable that security and connectivity. Now, this may look like your organization today, right? Depending on where you are in your cloud transformation journey. So, this architecture has served us well for many, many, many years, right? But with the hybrid workforce, with the applications moving to the cloud, this architecture would not be sufficient to provide the level of support, the level of agility that the end users need. Now, think about a problem happening when in this new world, right? With the users working from home, working from anywhere, uh, going via layer 7 proxies, connecting to VPN. When a problem happens, when the user is working from the office or in a hybrid workspace, it's extremely difficult to find and resolve the problem. Now, with Zscaler, like with us, we have pioneered a new approach to security and connectivity to the cloud, right? As many of you who are existing ZIA, ZPA customers would know, right? So Zscaler Zero Trust Exchange is a cloud native platform that acts like a switchboard. It verifies your identity, your context, and applies the right control so that to ensure you're not carrying any threats or leaking any information, and enforces the right policies. Now, while all of this traffic goes through us, we are sitting at an ideal place because the traffic is traversing through us. We are sitting at an ideal place to provide you visibility on how your end users experience looks like when they're going through us, or maybe in case of ZDX, even when you're going direct to the internet. So introducing Zscaler Digital Experience, right? So again, to summarize, multiple different tools. They are focused either on just the device, which are ITSM based tools, or just focused on network monitoring tools, right? Just like focusing on router switches, link speed, and all. And then cloud-based SaaS monitoring systems provide visibility into the overall health. But again, my they are siloed, do not share context, and if you have a problem, you are scrambling for information in all of these different places to correlate. So there is a manual correlation. With Zscaler Digital Experience solution, we are looking at the multiple different pillars. So we are looking at the application health itself, right? Well, how is the application uh, looking like from a health perspective? Is it responsive? Is it working? The path which we take through the zero trust exchange, so with the users when they're going through um, ZIA or ZPA, or when they're going direct, the path they are taking through that exchange to the destination application. Now, why is that important? So the traditional monitoring tools, they would not be able to provide you visibility into full hop by hop path view when you're going through a layer 7 proxy, or they would not be able, they'll just fail at the first hop as before you enter the layer 7 proxy. We talked about visibility into users home Wi-Fi and their ISPs, right? So what is users home Wi-Fi condition look like? Are they connecting to a legacy Wi-Fi network, like or a newer 5 gigahertz network? What does their ISP health look like, right? Are they connecting via VPN? uh, and then last but not the least, the device health itself. So is there any process which is consuming too much CPU or too much memory, or for that matter too much network on the user's device, which could be contributing to the problem which the user is complaining? And then further to that, we enrich all of this information which we collected with information from our ecosystem partners like Microsoft Teams, Zoom, and more recently introduced Cisco WebEx. We collect the call quality metrics details, and uh, bring them together with all of these different metrics which we collected from the application, device, ISP, Wi-Fi perspective. And then we are also able to run an AI driven root cause analysis engine on the top of these data points to enable your service desk, your IT teams to get to the root cause of a problem quickly. Now, how does that help you, right? So, uh, with all of this visibility at a single place, your employees, your end users, your IT teams are now able to, you know, resolve tickets quickly on the first call. So your level 1, level 2 service desk are now enabled to get visibility into the full application delivery chain, and then they can pinpoint and resolve tickets faster, making your end users happy, and then uh, minimizing all of these escalations to more costly level 3 escalation, level 3 engineers, right? So let's dive into some of the recent outages which we saw through our digital experience, the ZDX deployment in with Zscaler, right? And our customers saw that too. So the first one we are going to look at is the outage which happened, which impacted Zoom in September 2022, right? Users were unable to join meetings. They were getting, kicked out of the existing meetings they are on, and all of these problems related to Zoom, right? Now, what happened is that in ZDX, while this problem was happening, we looked at is there something wrong with our network? So we could see that other applications' health are absolutely fine. They are in the green category. There's no problem with other application access, but Zoom specifically saw a dip in their ZDX score. So as you see in the graph here, that the ZDX score for Zoom, it basically like went near zero, right? So moving on, we basically, were able to see, the ladder down when the service was starting to deteriorate, and all the way when the service, restored. And this whole the entire process, like the entire outage, was around 20 minutes. And during the outage we saw errors like 542, so basically think of it like as a load balancer which is eventually going back asking for a specific file or a service which is not accessible. So basically 542 indicates that while acting as a gateway or proxy, we received an invalid response from the upstream server. And so you see that here in the screen, the web probe which ZDX has was not able to reach out to the Zoom service for around 20 minutes. Now, as a service desk engineer, right, what could you have done when this problem started to show up and then resolved in 20 minutes? I think when users would start opening cases, and like, because Zoom is one of the critical services which like everybody uses today, right? So with ZDX, you could have been alerted that Zoom is experiencing an issue. And here what we are showing is, with our AI driven root cause analysis, we were able to narrow the problem down to an application level problem, but not an issue with the customer's local network. And how do we prove that? So basically, when the problem was happening, we could see that the network path itself was completely fine. We could reach the destination server, but it's the application which was hosted which was having problem. And sure enough, a few minutes later, after we got alerted in ZDX, we did see a notification from Zoom notifying about the problem, and how what were the different areas, what are the different geography which were impacted, and the resolution time. So moving on to the next example here, which is about a major Microsoft outage, which lasted around 2.5 hours, and this was in Jan 2023, this year, right? We see most of the Microsoft services which were impacted. So Outlook, SharePoint Online, um, most of the Microsoft SaaS services were impacted. Now, if we see here in this, these are the ZDX core dip and restore times for OneDrive, for SharePoint, for Outlook Online, and their recovery times. So again, think of it like when these issues are happening or when these issues are starting to show up, emerge. Lot of cases started to flow in. But again, if you have a solution which is monitoring the network, the path, the destination application, you could get alerted. A ServiceNow ticket could get opened automatically by ZDX and get you notified about that. Hey, there is a problem which is impacting your end users. Now, again, pretty much the same traits as we saw in the Zoom issue. We have uh, HTTP 543 error codes, which we are getting from the destination service. And then as we see, we used the ZDX based AI powered root cause analysis, which basically is, showing a problem at one of the hops in the Microsoft network, right? So if you can see here, there is like 226 millisecond delay uh, specifically within the Microsoft network. So it's not like where is the delay? Is it our network? Is it ISP? So we can pinpoint to that quickly. And Microsoft acknowledged that this was an issue related to a network. And I think, after the fact, this issue lasted so long, probably because of the internet convergence delay among the routers, right? So, and the last one, which we're going to take a look today, the outage, is basically the Google's service degradation. So this was in August 2022. Users start complaining about, inability to access Google. The web probes started to show a degradation again on, when did the service start to degrade, when did it start to recover, the entire duration time, with exact codes on why was the service unavailable, right? So we saw HTTP 500, 542, different error codes this time, right? But again, eventually the response codes which we saw was around 40,000 millisecond, right? Absolute, pretty much like unusable from an end user experience perspective. So yeah, basically indicating what were the different error codes. And then again, I want to call this out again, that when these issues are happening, your level 1, level 2 service desk can pinpoint to one of these locations, and uh, on a click of a button, they will get some assistance on why is this problem happening. We are looking at the data points before the service started to degrade and the service degradation point, and give you some analysis on what we think based on our AI is causing this problem. So a little bit more about this automated root cause analysis, right? So what we are looking at is all of these different data points, which is from the device perspective, the user Wi-Fi, the ISP issues, the network issues, think of it, because we are able to see the entire path through the application delivery chain. So if there's a specific hop which is slow, we would know that, right? The destination application, and we bring all of these metrics together, and we are also looking at the data points which we collect from millions of endpoints which we have from our user base, and we advance that machine learning as it learns from that data. So when an issue happens, as I mentioned before, we look at the specific data point where the user is looking of what went wrong here, uh, a few data points before and few data points after, so that we are able to accurately give you a verdict on what could have been impacting this issue here, impacting the user performance here. right? And then with our cloud path, now cloud path, it may seem like, oh, okay, nice, nice visual representation of a trace route, but I can tell you there's a lot which is going on in the back end to show you this entire path. And again, traditional monitoring tools, basically, which are just focused on network, would not be able to show anything after the local ISP's gateway, because once it goes through layer 7 proxy, your pings or trace routes basically stop working. So doesn't matter how your users are going to the destination application, direct, without ZIA or ZPA on, or going via ZIA, Tunnel 1.0, 2.0, via IPsec, GRE, and then out to the destination application, or going via ZPA, so going via the app connector all the way to the destination application in your cloud or data center, we are able to provide full path visibility there. So, any questions so far, please feel free to put in the chat window. I'll take a look in a few minutes, and I can answer that right after this. So, yeah, I think let's take a quick look at the demo, which is, I would say, more fun. Um, Let me bring my screen here. Just a second. Just a second. I'm bringing the demo screen. I'll give it a few minutes to load for all of you. It just takes some time here. Okay, so this is what the ZDX main dashboard looks like, right? And this is a demo environment, so not many users here, but then it basically shows you a full visibility into where all your users are and what their application visible application health, what their health looks like based on the probes which we have configured. So related to the talk track today, let's take a look at and a user which has been complaining about slowness with application access, and we don't know what's causing that, right? From a traditional way, we could go ahead and start a ping and start looking at the device statistics, but let's just start taking a look at the user. So the first point here is that when a user comes in and opens a ticket, we could go in here in the user search bar, look for the user. In this example, we are going to look for Quincy, who is complaining about the issues. So we click on the user, and then we could go ahead and select a range of data when the user has had the problem. So in this case, let's say we just select 12 hours, but we can go back, almost like we can go back 14 days in ZDX Advanced, and look for the data point here. So we have the user here, Quincy. We have the applications which are selected. We can remove or add the applications of interest. We are seeing the device details, the software level details. But what's interesting is there are dips in the user's ZDX score for all of these applications. So we are looking at ServiceNow, Salesforce, all of the monitored applications. We are seeing that there are times when the score dips into the poor category, the red area, right? Now, we now know that yes, user indeed is facing some problems, but what could this problem be? Why is this score dipping? We talked about multiple different pillars, like the device, the network, the destination application itself. Now, as we go through it, think of it like, how would you start troubleshooting it, without a solution which gives you visibility into all of these different pillars in one single dashboard. So here, when we see the score dips, we also see that the page fetch time, which is basically the time it takes to load or that certain application, it's increased vastly. It's like in the 5,000 millisecond area. The server response time has increased. The DNS resolution time increases when this problem happens, but the availability of the service itself is absolutely fine. So what it means is the service is available. It's just that the accessibility of that service is very slow. What we also see here is that when this problem happens, uh, there is an extended network delay uh, between the gateway, the user's gateway, and the egress router for that user, right? Now, we could see here that the problem is slowly inching towards a network problem, but where exactly, right? How would you know? And before we do that, let's go back and do a quick run of the Y engine, which we have been talking about, the AI driven root cause analysis. So what we can do here is we can click on analyze core, and you see this brain icon, which basically again is looking at the multiple different data points and trying to give you a verdict on what could have caused the problem. It takes a few seconds to load, but basically provides you whether it's the network, whether it's an application level issue, or whether it could be the user's device itself. So in this case, what we are seeing is that uh, let's read it out. So most of the monitored application indicate a low score, and this is likely due to clients, the end user's local system or the network, right? And the confidence level is 93%. Okay, so let's dig deeper here, right? So I would like to compare this poor score with what was it compared to when the users did not have a problem, and compare and contrast on the change, what changed when the user's performance dipped. So I would click on compare to last known good score here. And when I click on it, it is what it is basically doing is looking at that specific data point and then comparing it with the time when the score was green, and give you a side by side view of one versus the other, right? So on the left we have the poor score, on the right when the score was fine. You'll see that the numbers, basically DNS resolution time, page fetch time, all are up to the roof when we are looking at the low score, but they are in the normal category when they are when they were fine. Now, digging deeper here, it's basically like one path versus other. So when there was an issue compared to the issue was not there, and then what we could do is zoom into this area further, click on view detailed cloud path, and what you are seeing now is an top and bottom view of the problematic scenario versus when the problem wasn't there, right? Now let's click on this further, and when we expand this, we see that this specific router, which is 10.0.0.254, is inducing a lot of delay when there is a problem, right? 503 millisecond of delay, which is causing all of that slowness which the user is seeing. Now, this is an example from our lab environment, but I'll tell you that this is the exact same scenario we saw in one of our customers. And the issue was the router in question was having a memory leak, spiking up the CPU, and causing these issues. So with that, I'll just go back to our slides here. And then there are some information here which Rohit has written, an ebook on why network monitoring tools fails based on secure environments. The key point here is, which we briefly touched upon during the session, is legacy monitoring tools. They are not able to provide full visibility into environments, in zero trust environments. And how do we solve that challenge is covered in the first book. And the second one is the impact of siloed monitoring tools. So all of that is covered in this specific book here, right? Yep. So that's it. Thank you again. Thank you for taking time to join this session. Would love to hear your feedback in the comments. Feel free to put your comments in the chat window, and I'll answer that right after this session. Thank you.